let's get started. So, today we'll start understanding and learning about SQL. Okay, and before we actually get to the part of SQL, it is essentially very important that in the whole picture of data analytics and etc., where is SQL coming in? Okay, and what is SQL doing in all of this? Okay, so we'll need to understand about that a little bit. So before understanding that, we'll understand few terms that are going to be important in understanding the whole concept of SQL and etc. Okay, first term is data, right? There are different type. Data is basically the anyone who works with this field is very familiar with the fact that there are different types of data that we have here. Okay, different types of data that we work with and etc, right? So I think I have talked about this earlier as well. Can anyone tell me that what are the types of data that we usually work with? Any idea, anyone? When I say data type, what are the types of data that I'm talking about? Right, exactly. So, see, data is like the crude oil of information that we work with. But data in itself doesn't always come in the form that we have seen in Excel, right? So, data comes in different forms, and that data can be categorized into three main types. Okay, structured, semi structured, and unstructured. So data can be basically categorized into these three categories. Okay. It depends on how it is organized and how it is stored. Based on those, these three categories are basically created. Okay. First is structured data. Structured data is data that you actually have always imagined. Like whenever I say data, the imagination that you have, that rows, columns, a proper tabular structure, data that looks like data that looks like it is stored in Excel, right? That is basically structured data. Right? Basically data which is organized into rows and columns. So data that gets organized into rows and columns is basically the structured data. These are data that usually get stored in databases, and I'll talk about databases in a while. Basically, these are data that doesn't really need a lot of hassle because it's already stored in the most organized way. Okay, so it can be easily worked upon. Okay, so any data that you can imagine can be stored in rows and columns. Okay, so it's easy to store, retrieve, and etc. Right? Now, next I'll talk about unstructured data. What is unstructured data? Okay, cool. Data is unstructured because data has no fixed format, right? So when the data has no fixed format or no fixed structure, that's when it is called as unstructured, right? Data that has, it is not even, it doesn't even look like rows and columns, right? That is unstructured data. Okay, so data that you can see that, something which is stored in text files or images are also huge amount of data, right? Videos, social media posts, etc, all those are unstructured data because it has no It has no fixed format, it has no fixed structure, right? It of course can store huge amounts of diverse data. Diverse because you can store anything over here. You can store images, videos, files, etc. But the harder part over here is to search, work, retrieve information in these kind of data. So that's unstructured data. And now of course the semi structured data is the part which is a blend of structured and unstructured, right? So this is where it has some structure but is not truly organized, or truly, yeah, organized into tables. Okay, so data that has some structure but it is not completely organized into a table, that is semi structured data, right? It is something which has a partial tabular structure and partially it is unstructured. That's called semi-structured data. For example, very good example of semi-structured data. I'll type it also over here. Yeah. So a very good example will be emails. When you see emails, it has a part of the data which has structured fields. Like for email, you can always know that who is the sender, what is the subject, who is the recipient, and etc. These are things that you can put into proper rows and columns as well. The unstructured part in this emails is like the message body, right? The subject, that I mean the actual content of the email, that can have anything, that can have text, that can have images, videos, files, anything. So that's unstructured, right? And the other part is structured. Same thing with websites. Websites has a lot of thing which is structured, like for example the website's host of the website, or maybe the content of the website, like a table of contents of the websites and etc. But again, websites can be a mix of text, image, metadata, and lot of things. So again, that comes under unstructured. So this blend of structure and unstructured is what is making it semi-structured, right? So first thing, are we clear with this, that how data is of different types? What about others? Is everyone clear till here? All right, great. So big term is something that we have already covered, data, right? What is data and etc. and all of that, right? So now that we know data, think about it. What are we trying to understand over here? We are trying to understand that where is SQL falling in between all of this. And for that, the first thing is data. You work with anything, any business, any problem, anything, any real world problem or whatever it is, the first thing that comes into the picture is data. Without data, we don't have anything to go ahead, right? So data is like the basic thing that we get started with, right? Once we have the data, okay, once we know that, yeah, this is the data and this is what we are working with, there is something, the next thing, which is again very important and is basically called as database, right? This is where the story starts, right? So does anyone, I'm sure everyone has heard about database. Can anyone tell me what is database? What is your, like, understanding of database?
where data stores in a structured way,
Sorry, I couldn't hear you.
where data placed in a structured way.
Okay, okay. Format of data in rows and columns where place of the data is stored. Yeah. So, okay, fine. So, database is nothing but a structured collection of data. It's a structured collection of data. So, all the data that we talked about right now, if I have a place where I can store that data in the most structured, in the most organized way, that is basically called as database. Now, why do I say structured or why do I say organized? It's not just about the tabular structure which is making it structured, right? It is basically made in a way or stored in a way so that whenever whatever information I need should be easily accessible. That's the reason why it is called structured. If you have a cupboard at your home, right? Think about it. When you just dump in your clothes in the cupboard, when you just dump in all the clothes in the cupboard without any organization, it's very hard for you to every time find the outfit. If you want to find the outfit, it will become hard for you to find that outfit. But if you organize it, if you keep it properly organized, like work outfits, let's say gym outfits or party outfits, everything properly organized at their place, whenever whatever outfit you need will be very easily accessible to you, right? That's the concept that database also believes in. It is a structured collection of data that helps us in storing data efficiently, retrieving data efficiently, and manage all this information also in very efficiently. So if you talk about any business that works today, it cannot work without a database. Every business has a database because database is the place where it is storing its data. All these databases are basically then handled by different applications, systems, and etc. But the point of why databases are important is because of efficient data storage. That means I can store large amount of data in the organized way without any duplications and etc. I can retrieve my data very quickly, right? I can ensure that the data is consistent and there is no unauthorized access. That security is also very important in data, right? It's the crude oil. This is the most costly part of any company, right? So it should be secured. And with database, your data is secured. It's consistent, it's secure, right? Then fourth thing is also the fact that it can handle immense amount of data. So if your business is growing, your data will also grow, and database is something that can handle that scalability, right? So all of these reasons are the uh, you know good part of starting with what is database and why it is needed in this whole picture. Was that clear for everyone? Okay, great. Now, even in database, there are different types of database, okay? Lot of different types of database, okay? We will talk about the most commonly used or popular ones, okay? The first one is called RDBMS. Anyone knows what is RDBMS?
Relational database.
Okay. So see, there are various types of database. Everything is designed for specific use cases. RDBMS is basically nothing but relational database. And the full form is Relational Database Management System, right? So whenever the term DBMS comes in, DBMS is nothing but Database Management System. And database management system is nothing but a software. A software which basically manages and stores databases. Okay, so when I say RDBMS, it's Relational Database Management Software, okay, or system, basically, right? So yeah, talking about RDBMS, RDBM is the whole point of how, and this is the, by the way, most popular one. Okay, this is the widely used one as well. So RDBMS is basically the one which stores data in the form of relational databases. Relational database means stores firstly data in tabular structure, which means with rows and columns. That's the main part of RDBMS. That data stored in RDBMS is structured. So everything is in the form of rows and columns. And data tables here can be related to each other, which means I can relate the customers to their orders. I can relate orders to their seller. I can relate seller to the inventory and all of that. I can actually create a meaningful database storage over here because I can relate tables. I can create relationships between tables over here. When you create relationships between tables, you create the idea of joining tables or merging information or creating that opportunity where you can combine a whole lot of information together to be able to solve the bigger picture over here, right? But the main part of relational database is the fact that it stores data in tables with rows and columns, right? And examples of RDBMS is MySQL or SQL Server or Oracle, PostgreSQL. These are all relational database management system, right? Like use cases can be anything over here, right? Banking, online stores, business applications, everything. Mostly data over here gets stored in rows and columns. Like everyone prefers a structured data. So if the data can be organized into rows and columns, then definitely in every company there will exist a data pipeline which will extract the data and basically get it into the form of rows and columns, and then it gets stored in relational database management system where we work and get the data queried, analyzed, manipulated, modified, etc. So RDBMS is clear for everyone. Great. Another type of database which is again a popular one is called NoSQL. NoSQL database stands for not only SQL, right? So this is the database which is a little different because this stores data in a very flexible, non-tabular form, right? So this doesn't enforce a tabular structure on the data. This actually can store data in a non-tabular format as well. That means this can store unstructured or semi-structured data. This is the database which is used for unstructured and semi-structured data, right? For example, MongoDB. If you have heard about MongoDB, it's NoSQL database. Okay. Then there is Redis, which is again a NoSQL database management system, etc. So all social media apps, if you have noticed, social media has a lot of unstructured, semi-structured data. For example, the post, the comments, the images, the stories, everything, all of that can be put in the format of semi-structured or unstructured. So social media apps like maybe Facebook or Instagram, they use a NoSQL database. Okay. Um, Even websites, though they will also prefer using NoSQL database, etc. Right? So that's about NoSQL database. Is that clear for everyone? Other than these two main ones, there are a lot of other type of databases as well. Like one of them is called graph database. Graph database is a little different than the other ones as well. This what it does is stores data as nodes and relationships. Like everything is node and how that node is related to the other nodes, right? Instead of tables, it basically stores in nodes and relationships format, right? The example over here will be something called as ArangoDB. If anyone has heard about it, ArangoDB is basically a graph database, not widely used. Okay, so in this, how the data is stored, I'll show you an example. So let's say you're storing friendships. So you will basically be like, maybe Raj is a friend of, so friend of is the relationship, and you will write friend of whom? Let's say the friend of Rahul. Like this. This is how the data is stored and very not very consumable. It is a little hard, not that flexible. But few companies do prefer using graph database. It's very rare that they use, but yeah, it is some it's some companies definitely use these up, right? So till here, is it clear for everyone? So just to summarize the fact that databases are nothing but the backbone of the digital world, right? Whether it's relational database for structured data or NoSQL database for unstructured or semi-structured data, businesses completely rely on them for everything, for efficiency, security, everything, right? And the fact is that these databases are managed by a software which is called database management system, right? For example, MySQL Workbench is a database management system. Inside MySQL Workbench, you can store multiple databases. In each database, you can store multiple tables. Those tables can be related to each other if you want to, and etc. So that's how the whole hierarchy is, right? So understood the context of what is database and where is the data getting stored. First thing. Okay. Now coming to the most important part, SQL. Now before I even start with SQL, let me tell you that one of the most used tool in data analytics or even in data science is SQL. SQL is like heavily used tool. So if you want to become a good data science professional, you need to master this in the best way, because everything can has to start with SQL. It's very important basically, okay? So SQL basically stands for structured query language. It's a language, okay? It's a way you communicate with data. It's a way you communicate with data stored in databases, basically, right? It's a programming language, basically like a programming language which can store, retrieve, manage data, everything present in a relational database. Okay. SQL works on relational database. Okay. So I'll type it also over here for notes purpose. Store, retrieve, manage data stored in RDBMS. Okay. So it's like a conversation. It's like a conversation that you have with a database. So if you ask questions, it will give you answers. That's the whole concept of SQL. You ask questions to the database, it will give you answers. And by that, you can manipulate data, you can modify data, you can find insights or information in the data, and you can do everything using this same format present. That's SQL, right? I'll give you a simple example to understand the whole picture. Okay. Let's say there is a uh, let's say there is a large e-commerce company. Okay. Let's say there is a e-commerce, any e-commerce company. Okay. That e-commerce company will have many parts of their data, right? They might have customers, they might have their products, they might have their orders, and etc. Think about it. They might have customer data, they might have products data, they might have orders data. Here, if you notice, customer can be related to orders because every customer will place a order. Or more, one or more than one, of course, orders will be placed over here. Then every order will relate to what products were bought. So everything is related to each other. So this is how your database, relational database will look like. Okay. Now here, if you want to search for customers, let's say you want to find customer details who bought mobile phones under 20,000. So when you search for this, instead of going through the data manually, you can just put forward this query or this question to SQL. I mean, using SQL, you can put this to the database and it will basically run in background and fetch you the relevant data. That's the whole story of database management system, SQL, and how it is working to get you the data. Got the point now? Manish, I'll answer this question at the end. Okay, cool. Everybody clear till here? Any questions, any doubts till here? Okay, no questions? All right, cool. The SQL data, I mean the database software that we will use is MySQL. Okay, so before I start, just a question to everyone. Has everyone installed MySQL Workbench successfully? Have you set up the connections? I had forwarded two links. If you go through the link, you will set up the connections also successfully. Have you guys done that? So I knew there will be problems. Like I knew there will be problems of connections and etc. That's the reason why I recommended you to give it time and go through the video. So connection is not happening. So we'll have to see why it is not happening. Okay. So it's when you install MySQL Workbench, after installing, you have to set up connection also. Once your connection is successfully set up, only then you can open MySQL and work with it as well. So the connection part is very important. Okay, so we'll see why the connection is not there. Okay, but before that, to talk about MySQL a little bit, MySQL is nothing but a relational database management system That's the one that we are going to talk about, work with. Why we choose MySQL usually is because it's the most used database management software. Now, understand this, that when you work with a real company, they might or might not use MySQL, okay? But MySQL's syntax is the basically the code that you write, right? Is something which is widely acceptable. So if you learn MySQL, you can pretty much code in any other relational database management system, be it SQL Server or Oracle, right? The syntaxes might be a little different, like maybe 5% different from each other, but majority of it is similar. Okay. And if you don't follow this approach, it will be impossible for you to go and learn every database management systems language. It is nearly impossible, right? So that's why it's better to follow one. You can start with MySQL. Everything is pretty much same. And I'll tell you simple differences. Like here, if you use the function AVG, which computes average, in SQL Server, you will use a average, the whole spelling of average. So that's it. The main concepts and everything is same, exactly same. It's just the function names, which is a little bit, or the keywords, which is a little bit 1920 differences present in different, different softwares that you use. That's one thing. Second thing, in real world, in companies, when you work with a, big company, mostly everyone has their own query tools which they are which they have built in house, and specifically product companies. All product companies have their in-house query tool. So there, even if you learn MySQL, SQL Server, Oracle, no matter what you learn, you will be using something entirely different. That's common, right? Because it's an in-house tool, so you won't be able to learn it from outside. Once you get into the company, only then you will be able to work on that. So again, whatever they build, whatever in-house tools they build for querying and storing the data and being able to work and query and manage and manipulate data, everything is very similar to MySQL. So that's the reason we always choose MySQL to learn first, because everything else becomes easy to learn once you learn MySQL basically. Is that clear for everyone? All right. Cool. Just give me 1 minute. I'll just grab some water. Okay. All right. So now what we will focus on is the data that is getting stored inside MySQL. We know that only tabular structured data is stored inside MySQL. Okay. We know that data is stored inside a database, and inside a database, multiple tables are stored. So how it works is, see, this is the whole database management software, the BMS. Inside DBMS, you have multiple databases. Multiple databases can exist in one database. So it can store huge amount of data. Inside one database, there can again be multiple tables. Those tables may or may not be related to each other. Completely their use case based. So this is how the whole structure basically is. Now inside a table, you have rows and you have columns. So these columns basically represent what is this data about. Like if there is a column called amount, it is representing something which is numerical in nature, right? Something which is in number, which is numbers in nature. So we are talking about that next. Okay, we are talking about the data types that can be stored inside MySQL's tables. Okay, data types. Data types is nothing but, what I mean by data types is what kind of data can be stored in in tables column. Okay, so choosing the right data type is very important so that you have the right efficient storage and you have a good performance as well. So choosing the right data type is very, very important. So we'll talk category wise. Okay, the first category of data types is numeric data type. Numeric data type in the sense something which is in the form of numbers, something which is used to store numbers. Okay, used to store numbers. For example, I mean, there are multiple numeric data types. Okay, MySQL has a lot of data types. We'll again understand the most prominent ones because it's not possible for you to even remember all the data types. Okay, so you should learn and focus on the most relevant ones. Okay, the first one, the first one is int, the most common one. Int means integer. Int means integer. It can store a maximum of 4 bytes of memory, and int is only used to store whole numbers, numbers that have no decimals. For example, if you want to store age, age is usually in whole numbers. We don't write age as 25.5 or 26.2. We don't write that, right? We'll either write 25 or 26. So age. Then what else can be integer data type? Quantity. Even quantity sometimes can be in integer data type. And yeah, there can be multiple such examples, right? Which can be of integer data type. So that's int. Okay, same way you have something called as big int as well. Big int is also used to store integers. It's the same integers, but it's just that you can store very large numbers, right? Like there is a difference between storing a number like 100 or a number like something which is maybe 100 billion. So that number is huge. So for storing such very large numbers, you can use big int data type, which can give you a maximum size of 8 bytes. But if you are not storing a very large number, then it's better to use int, because int uses lesser memory. The lesser memory you consume, the better, faster your process will be. So you should choose the right data type based on your use case. If you want to, let's say, store something like populations or followers, which are generally big numbers, then in those cases you can prefer using big int. So that's about int and big int. That was clear firstly. Okay, cool. Next one is decimal. So we write it as decimal and in bracket x comma y. Okay, that's decimal. Okay, so decimal is something which can store decimal numbers, the numbers with decimal point basically. Okay, and these are like, again, this is a variable size. It depends on you. Okay, how much you want to store, and you can store columns like price or maybe weight, height, etc. Okay, that's decimal. Okay, and but decimal is a variable size. It can store any amount of size over here. Okay, and the x comma y is basically to talk about how much how many numbers you want to store before decimal point, after decimal point, and etc. Got my point? Yes, it is referring to a data type which is storing exact numerical values, right? Designed for, very precise calculations. And it doesn't, it's not about rounding errors. It doesn't round error. It stores the exact values. So if you write, for example, this X and Y, if you're asking me about X and Y, X is basically nothing but the precision, and Y is nothing but the scale. Okay. Precision basically means the number of digits that can be stored both before and after the decimal point. And scale basically means the number of digits that can be stored after the decimal points. So when you write a decimal 10 comma 2, 1 second. So when you write decimal 10 comma 2, this means this particular column can store numbers with a total of 10 digits, and of those 10 digits 2 can be stored after decimal point. That's what it means. So now is that clear? It's very ideal for monetary data or wherever accuracy is very paramount. This That's where we basically choose to use decimal. You can you can store integers with decimal also. It's there. But why will you store that? Integers are something which is not supposed to have decimal point. That's why it is representing that it is a whole number. If you store it as a decimal, you're changing the whole representation. Plus, the whole use case changes in that case, right? If you write someone's age, logically it is represented as 25, not 25.00, right? That's the reason why it is better to store it in integer. You got my point? Because integers in itself is very, very efficient and compact. So if you can store something in compact efficient manner, then why not? That's the point. Got it? Is everyone clear till here? Total 10 digits in example also includes 2 digits after decimal. Yes. Yes. Total of 10 digits, out of which 2 will be after the decimal point. Got it? Krishna, is it clear? Okay. Cool. The other data type to store decimal numbers is float. You can store float. Float can give you a maximum size of 4 bytes. Yes, and it is designed again to use decimal numbers. But float basically stores decimal numbers, like for example, if you want to store again something like weight, height, etc., their float is basically used the most. Got it? Okay. Is that clear till here? And why will you choose to store something in float when you can already store it in decimal? There are different use cases behind it. Okay. See, float stores numbers like floating point numbers, basically numbers with decimal points. Okay. So that means over here, I mean, float basically is generally it is faster for calculations. Float requires less storage space, it's just 4 bytes, and it is faster for calculation. So it's very suitable for applications where performance is very critical and etc. So scientific calculations, any kind of engineering application, you will use float. But decimal is used to store exact numerical value, exact fixed point arithmetic value. So in decimal, if you have said that the scale is 2, that means every number will have exactly two numbers or two digits after the decimal point. That is not the case with float. You can store any variable number of digits after decimal point. So decimals are ideal for financial data. Float is ideal for scientific calculations and etc. So it depends on the use case that you're using. Got it? Is it clear till here? Decimal is variable size. There is no limitation on that. Everybody clear till here, guys? Great. Next is string or character data types. Basically, data types that is used for storing words, text, sentences, etc. All of that basically is taken care by string data type, basically. Okay. Okay, so the first data type in string is char. And when you write char, you also mention the size in bracket. So when you write char n, it is basically meaning to say that you are defining the data type as char and the size of the data type is n, right? So this char basically has a fixed size and that size is determined by what you write as n. Okay. So this is completely used for fixed length text. So for example, if you define char of 5, here every value in this column will have exactly 5 characters. That's the limitation of using char. Every value will have exactly 5 characters. The length of every value will be exactly 5 if you define char as 5. It's a fixed length characters. Of course, it has a limitation. The limitation is that it can store, like you can declare with 1 to 255 characters, anything between 1 to 255 characters. But when you declare char as let's say 5, it has to exactly be 5 characters. Every text that you enter or every value that you enter in this particular column will be exactly 5 characters. Nothing less than 5, nothing more than 5. That's the limitation of using char. But why is it useful? You can use it in columns like gender, where you know the values will be F or M. If you know that it will only be F or M, you can store it. I mean, you can use F or M and you can store using char of 1, right? Or when you know that, for example, there is a, like a, let's say some kind of registration ID. Registration ID, you know that it will always be of 10 characters. You know that no matter what, it will be 10 characters. So in those cases, you can use char. Is that clear? That first thing is clear for everyone? Okay. Next, to overcome this limitation, you have something called as varchar. Again, whenever you declare varchar, you will also declare with its size. Okay. Varchar is variable character. So that means the size is also variable. It is variable character, which means that if you declare varchar 10, if you declare varchar 10, here you can store anything but of max length 10. Like every value in this column can be any number of character between 0 to 10. It can be 0 characters, 1 character, 2 character, anything, but the maximum limit is 10. It's like you're defining a maximum limit. It can't be more than 10 characters long. That's what is varchar. And this value 10, again, it can be anything from 1 to 5, 535 characters. Right? That's called varchar. So if you want to store something like name, names can be of any character. My name is of five characters. Maybe your name is of 8 characters. Maybe someone else's name is of 4 characters. It is variable in nature. So in those cases, you can use varchar. Or for example, product details and etc. Got that? Is it clear till here? Now, what if you want to store paragraphs? Paragraphs are huge amount of text, right? What if you want to store sentences after sentences, like a whole paragraph? In that cases, you can use a data type called as text. Text is used to store large text storage, basically like paragraphs. If you want to store paragraphs of information, you can store it in text because it has the capacity to store variable amount of data over here, right? So these are basically the most prominent string or character data types that we have till here. So everybody clear till here? Okay. Next up, we have date and time data types. Data types that basically help us storing, timestamps or dates. For that, we need date and time data types. Okay. And again, this is a very important data type because a lot of times you will work around with dates, you will work around with time stamps, and maybe you need to extract sometimes, you maybe need to manipulate sometimes, or maybe you need to add, subtract. You can do a lot of things with date and time. And again, to simply clarify, you can store a date as a string as well. Like inside a string you can store a date, but why do we need specifically a date or a timestamp, etc.? So that we can specifically work and manipulate this kind of data. Something which is in date data type or data time data types, that can help us extract year. Let's say I want to extract the year or the month or the day. I want to understand which day was it. Or let's say I want to find out what was the date 10 days before this particular date. All of those operations I only can do when it is in proper date data type. If it is stored as string, I can't do these kind of operations on it. That's why firstly it is very important to maintain the data types. Okay. Inside date and time data types, the first one is date. Okay. It can store it with a maximum size of 3 bytes, and you don't need also more than that because date is always fixed, right? It will be year, month, and date that you can store. Okay. So this is only used for storing only date basically. Okay, only date. So for example, if you're storing birth date or date of joining or date of birth and etc., you can use date. Then you have date time, which can store a maximum of 8 bytes. And this is used to store date plus time. Also, one thing if you should remember that MySQL is very strict when it comes to formats. Okay. And the date format that MySQL exactly follows is year in four characters, year hyphen month hyphen date. So that means the acceptable format is 2025 03, exactly this way, with the hyphens and the number of digits exactly this way. And today is 9, so 9. Right? This is the correct data type. If you write something like 0903 2025, that will be wrong. The only acceptable format for date is basically year, month, and date in this exact format. That is the exact format that you have to store date in. If you try to store it in any other format, it won't get stored as a date data type. It will get stored as a string data type, like a varchar. Okay, so if you want to store it as a date, you have to maintain this same format. There is no like leniency in that. Okay. Same with date time. When you're storing date time, again the date will first come in the same format, and then space, and then hour, colon, minute, colon, second. It has to be exactly in this format. Same, then there is timestamp, which is another data type over here, which is again of 4 bytes maximum size. And it is used to store timestamp values. Okay. This is again something which again can basically these are auto updating ones, updating timestamps. Like it will tell you what is the date and time right now and etc. So this is again in the same format because it's timestamp. So it is in auto updating mode, right? So it will always get updated, right? Like for example, right now it's 9th March 2025, 10:36 a.m. In the next minute, it will be 10:37 a.m. So for representing that kind of data, you use timestamp. Other than that, if you just want to store time, you can use time data type as well, which is again of 3 bytes. Stores it in the format of hour, minute, and second. Got? Is it clear till here, everyone? Uh, Raghav, that's how it's built. Date time can store it up to 8 bytes, but timestamp is always fixed to 4 bytes. It is how it is built in the backend, basically. Same amount of data, but timestamp is in auto updating mode, right? So it is built this way, basically. So timestamps usually is like, for example, current timestamps. Now there are functions which stores timestamps, which we will see when we explore date and time. So you can see that it will always get updated. So it has again a very different backend working for it. Okay. So everybody clear till here? Okay. Other than these main data types, there can be other miscellaneous data type as well. Like one of them is Boolean. Boolean is basically of size 1 byte because it stores either true or false. Like it can have only two possible values, true or false. Okay. So it's used to store flags like, for example, is active. Is active can be either true or false. Or example can be, let's say, is salaried employee. So the the field value can be true or false, representing whether a person is a salaried employee or not. Okay. Then you have something called as blob. Blob is basically nothing but binary large object. Okay, so this is where relational database management system can partially store semi-structured or unstructured data partially. Okay, so it helps us in storing binary data like images and etc. So images and videos, they basically get converted into a binary form, and that binary form is basically stored in binary large object base. Okay. So these are mostly the data types that we will be working with. Is this clear till here, everyone? The data types, everybody clear, right? Okay. So don't worry about notes. I will forward you this exact document. So if you want to rely to the notes that I am writing, you can follow this document. And I will suggest that on all the classes that we are having, it is good if you maintain your own notes as well. Right? Anyway, when we do MySQL like in hands-on, I will I will write a lot of codes. I'll make you also write a lot of codes. I'll make you also practice and execute right then and there. So you anyway will maintain and practice right side by side. If you want, you can note these side things. Like if you find something important, you can keep a pen and paper to just note this important side things. Okay, so that later on, you whenever you want, you can come back and just revise on the same topics. So it's on you. Okay.
Meghna, can you repeat BL verb?
I
I
couldn't hear.
missed it.
Can you come again?
Hello, hello.
Yeah, yeah. Go ahead.
Can you repeat? Can you repeat BL verb?
BLOB. Okay, blob. Blob is basically binary
Yeah.
large object. Binary large object, it's a data type which is used to store binary data. This is where relational databases can partially store a little bit of semi-structured or unstructured data. So it's particularly useful for storing files like audio files, image files, video files, etc. They're designed to store large amount of binary data. So the data that gets stored over here is to gets stored as a binary object, but actually it's a image or a video. You can't view it, you can't see it, but it gets stored in a certain binary format basically. That's blob. Got it? Okay, cool. Now we understood, see, now the picture is that we understood the data also. We understood the databases also. We understood how it is getting stored. We also understood that the data that is getting stored in all these tables and etc. What kind of data can get stored, right? Now we will explore a little bit about MySQL's working. Okay, like everything that you write in MySQL is a command, right? It's a command because it's like a question that you're asking database and the database is giving you an answer based on that. So there are different formats of asking this question, or there are different formats of putting this question to database. And that though those are the things that we will focus on right next. We'll focus on something called as commands. Okay. Commands basically are nothing but the the point that you're putting to MySQL. If you're asking MySQL to, like, if you're asking the database to fetch you something, that's a command. If you're asking MySQL to, let's say, go ahead and, let's say, modify something, that's a command. So there are different kinds of command that we use in MySQL. And right now we are going to work and understand the different commands that we have, and only then we can go ahead and learn each command in detail, right? Okay, I just fixed my audio. Can you guys hear me now? Okay, great. So I was talking about the fact of commands, and I was saying that we will now learn the different category of commands that we have. Okay. So mainly there are five categories of command. Okay. The first category is called DDL. DDL is nothing but data definition language. These are all SQL, like these are all part of SQL. SQL is the structured query language. Inside SQL, when you write codes or when you write syntaxes, there are different categories of codes that you can write, like different categories of commands that you can write. Okay, so we are learning about that. So first one is DDL, data definition language, which is used for creating and modifying database structures. Completely used for creating and modifying database structures. Okay. So anything that helps you define the database structure, modify it, create it, everything related to the structure. If you understand structure, it means the columns that we have, the database that we have, the name of the table, the name of the database, and etc. So commands like create, alter, drop, or truncate, these even rename, actually these are all DDL commands. Like create helps you create a new database or create a new table. Alter helps you modify an existing table. Okay. Drop, I mean, by modification I mean you can add new columns, you can modify columns, you can delete columns, and etc. Then you can delete an entire table using drop, you can delete the rows using truncate, you can rename an existing table. All of that you can do using DDL, because everything over here relates to the fact that you are manipulating with the data that is present in the database. And for that, I mean, you need a database structure in place, right? So DDL helps you with that. Next is DML. DML is nothing but data manipulation language. Okay, these are commands which is used for modifying the data which is stored inside the tables. Okay, this is used for modifying data stored inside tables. So if you understand the difference, with SQL you can do everything. Okay, you can communicate end to end with the data and the database with SQL. That's why SQL is so popular. So even if you have to fetch some data, even if you have to do anything in the data, you need SQL. So be it the fact that you can work on the structure of the databases or the tables, you use DDL. If you want to work on the data that is stored inside the data tables, if you want to modify it or manipulate it, you will use DML, data manipulation language. Okay, it will basically not do anything to the structure but modify the data stored inside the table. Okay, so for example, insert is a DML command. This will help you add rows to your data. Okay. Even update is a DML command because it will modify the existing data. Then there is delete, which will remove data from particular table. These are all DML commands that we have. Okay. So till DML, is it clear for everyone? And I just want to understand if you're understanding the whole story of what SQL is trying to do and where is SQL playing a role. Is everyone clear with that? Because I'm trying to depict that again and again. Is that clear for everyone? What about others? What do you feel? Okay, cool. Next is DQL, Data Query Language. This is where you actually query the data. This is where you write commands for fetching data. So it helps you in retrieving data from database. So whatever tables you need, whether it is one table, two table, or multiple tables that you need, if you want certain information to be fetched, from multiple tables or the databases, you need to use DQL. And the only command in DQL is select. That's the only command available. Okay, it's just used to fetch data from tables. Okay. The fourth one is TCL. TCL is nothing but transaction control language. This is where you can manage your transactions, which means you can ensure over here with these commands, you can ensure data integrity. Okay, when you're making multiple changes, this is where you can ensure data is consistent, data is accurate. Okay, for example, the commands that we have over here will make sense now, like commit or rollback, etc. Save point. Okay, so commit means that whatever changes you made to the data, whatever modifications, changes you made to the data, if you want to save all the changes permanently, okay, if you want to save all the changes permanently, you need to use commit, because there is no undo in MySQL, right? If you do something, you do something, there's no going back. Okay, so commit helps you save all the change permanently. So if you have committed all your changes, that means all your changes are now permanent. There's no way you can go back. Okay, so when you're very sure, you do commit. Then you have rollback. Rollback is a sort of undo. Okay, so you can undo changes that you just made. Let's say you tried to do certain updations or certain modifications, but you can see that certain kind of error is occurring. So in that case, you can do a undo and you can use rollback for that. And then a similar, use case is solved by save point as well. Again, helps you roll back and get your data sorted till a specified state and etc. That's TCL. Okay. And the last command is basically called DCL. No, you can't roll back after using commit. Once you have committed, you're committed. You have saved all the changes permanently. Even rollback can't help you. But if you have made some changes and you have not committed, then you can do rollback. Safe point. When I talk about TCL, I'll talk in detail because you might get confused right now. But still, because you asked, I'll just say it. That let's say you made these many changes. You did these all changes, okay? And let's say you created a checkpoint at this step. Maybe you at this step you have created a checkpoint because maybe you are sure that till here all the changes that you did are correct. You're 100% sure. But you didn't commit, you just created a checkpoint. Now, after this checkpoint, whatever changes you do, if something happens, if anything goes wrong, if you do a rollback, it will roll back till this checkpoint. It will basically roll back till this checkpoint. So whatever changes you did after this will get undone and it will come back to this state. So you can define that state using save point basically. Got it? Yeah, only if you don't use commit. Yes. Commit means permanent. Nothing can be done on top of it. Got it? Okay. So TCL is data control language. This is the language or this is the command, more of command that is used for permissions and security. So if you want to manage user access and who can access your basically who can access your data, who can access your database, or what is the security that comes in, then you can use TCL. Okay. So for example, grant and revoke. These are the two commands in DCL. Grant will give a user permission to access your data. Revoke will revoke the permission from the user. Right? So is this clear till here, everyone? Okay, other than these commands, there is a separate set of commands called data administration commands. Okay, data administration commands are basically used to manage and interact with the database. Okay, I will talk about it in detail when we just in few minutes we'll see the practical hands-on. I'll talk about that in detail. These are basically used to manage and interact with the databases. Okay, so they are not under DDL, DML, DQL, and etc. that we learned till here. They're a different set of utility commands. Okay, and actually two most prominent commands out of them is show and use. And we are going to use them just in few minutes. Okay, so we'll see the use case of this. Okay, but I just want to know if everybody's clear till here. Right, great. Now let us open MySQL Workbench. I'll just open MySQL Workbench. Okay. Okay. So this is your MySQL Workbench. This is your software where you store databases, and inside databases you can store multiple tables and you can store multiple databases also. Okay. So if you see, I have a lot of database over here. Okay, I'll show you. On the left hand side is where you get to see your schemas. Schemas is nothing but your databases. Schemas are nothing but your databases that you get to see over here. Okay. So, and I have a active connection. That's why I'm being able to see all this and etc. Okay. Now, these are your schemas, these are your databases. If you see, these are all different databases. Inside every database, you can see there are multiple tables that are stored. If you click on any table, you can see the details about these tables in the lower section. This is where you get to see the details about the table, like what is the table name, what are the columns, the data types of those columns, and etc. So this is the schema place basically. Okay. On the left of schema, you have administration. This is where this is where it has everything to do with management of your SQL workbench. Okay, so it will show your server status. Like you can see the server status is running for me, my CPU load and my performance, what is my versions and etc. Like it's like about section, nothing but the about section. So yeah, that's server status. You can see your connections, you can see your server logs. Like basically this tells you how your MySQL workbench is performing. Is it active, is it inactive, what is happening, everything you can see over here. So that's about schema and administration. On the top, this is the taskbar. Okay, this is where you have, if you see the first symbol, it's called plus SQL because this is helping you create a new SQL tab. So when I clicked on it, this particular SQL tab got created. This is where I will write and execute my queries. I can write n number of queries inside this tab. Inside this white space, I'll write my queries. I'll write my codes to be able to work with the database. Okay. And this is one single SQL file or one single SQL tab. Same way, after that, the second option that you can see over here, this is basically used to create a SQL script file, like a whole. See, the difference between tab and script file is in tab, you can write multiple queries and you can keep on executing them as and when you need it. More useful for exploration purpose. SQL script file is that when you know this is one query that I need. So you will create a script file that will have the entire query, and that will be like one query, and each time you run that, maybe you can perform a particular operation. So useful when you want some kind of raw data to be fetched every time. Okay. So yeah. And then you have options to create a new database. New schema means new database basically. You can create a new table inside the database and all of those options. Okay. That's about taskbar. This is the white area I already talked about, right? This is where you write your codes and you execute them. And for executing them, you have multiple options over here. Like the first option is definitely to save the file. Then you have the flash buttons for running and executing. We'll see that when we execute. You have limits and you have all those, um, formatting options and etc. over here. Okay. For script, I basically said that firstly, SQL tab is where you can write multiple queries. Okay, it's for exploration purpose. If you're exploring, doing small operations and etc., you can write it in SQL tabs. You can write multiple queries. Versus SQL script file where you can write one big SQL query. Maybe this SQL query, I'm just giving an example. Maybe the SQL query is supposed to fetch a raw data for you, which raw data you might be using this raw data further for any other purpose. And you always need to run this again and again to get a raw data. So you can store it in a script file. When you run the script, every time you will get a raw data fetched. So it's like one big SQL query. That's it. Got it? Is it clear? Okay. And here in the bottom part, if you see, this is action output. Action output is basically the area where you will get to see whether your command ran successfully or does it have an error. So whenever you see this red cross means there is an error that has happened. So whatever command you tried to run, that had an error. And it will show you what error it had. Okay, that's the red cross. If it is green tick mark, that means the command that you ran successfully. So that's why it has a green tick mark over here. That's action output. In the action, on the above part of action output, if you see, there are two gray dots. Small, there are two gray dots. The below one is for action output and the upper one is for result grid. If you just drag it up, you will see a gray area. It is right now a gray area because we don't have any result right now. When we run a query, when we get a result, this is where the result will get populated basically. Right? So that's about the user interface that we have in MySQL Workbench. Is that clear for everyone? Just give me 1 minute, guys. Okay, sorry. Yeah. So that's about the UI that we have in MySQL Workbench. Okay. Now tell me something before I start showing you commands and before I start showing you, and let's say not even showing, before we start learning about commands or working with data over here, what is something that we need before anything? What do we need? First thing that we need over here before we do any work. Data, of course, we need data, right? And where will we store the data? database, right? So that means we need a database first, right? That means we need a database first. Okay. Now, one more thing is that in this whole SQL, apart from writing your proper commands and etc., apart from writing proper commands and etc., you also need to, I mean, not need to, but you can also include comments. Like if I write double hyphen space, this is a comment. If I write, for example, database. Okay, so this is a comment. The first line is a comment. It's just for readability purpose, just for more readability, more clarity, more code hygiene, and etc. This is a part which doesn't get executed. Okay, comments are just for textual purpose. That's it. Okay, so I will be writing a lot of comments throughout the SQL file because you are learning for the first time, so it will be easier for you to understand the code if I write comments. Okay, so database. First thing is database. So I need to create a database. Okay. Before anything, I need to create a whole new database, and in that database, I'll start storing my data. Now, before we start doing anything practical, I just want to clarify everyone that there is a format that I follow while I teach MySQL or anything like this, okay? Uh, the simple rule that we are going to follow is that because it involves a lot of steps, lot of explanation, lot of codes and etc. I will tell you what is the code, what we are doing, what can be done, why we are doing it. Like I'll tell you everything about that particular part, okay? Whatever I'm explaining, I will tell you everything about that part in detail. I want you to focus only on the screen while I'm explaining, okay? Don't try to parallelly do the same thing. If you try to do that, you will miss out on details and you will miss out on a lot of things, and that will basically that will basically put you on a spot. Okay, that will basically not help you progress, but you will instead slow down. Okay, so just focus on the screen, just see what am I doing, why am I doing whatever I'm saying, just hear me out. After we are done, I'll ask you if you're clear, and then I'll give you time to execute the code on your own, and only then we'll move forward. Okay, so can we all abide by this format? Okay, great. So the first thing that we'll do over here is we'll create a database. On the left, if you see, I already have a lot of database, okay? So in this database, like I said, the tables are stored. So I also need to create a new database because this is the first time we are working towards we are working towards understanding MySQL. So we will start creating a database, okay? There are two ways to create a database, okay? One way is by using the taskbar, by the auto created menus that we have. Other way is by writing a code. By writing a code, how can I create the database? I'll simply use my DDL command, my first DDL command called create. Create is a command that helps you create a table, create a database, and etc. So I'll over here create a database. I'll write create database. That means I'm trying to create a database, and I'll give a name for this database. Let's say the name that I give for my database is what name can we give? Okay, I'll give the name sample t. Okay. I'll give the name sample T. You can give anything that you want. Anything that you want, you can give as the name in this database name. Just make sure it doesn't have space. Okay. Other than that, just make sure it doesn't have space or special characters. Other than that, you can give any name to your database. Okay. I have given sample T. Now to run this command, I have to run this command to be able to execute it, right? So what I'll do is I'll select this command. I just want to run the second line, right? So whatever I want to run, I'll just drag and select that part. Now there are three things over here. The first flash button, if you see, the first flash button, the yellow flash button, this is used to execute the selected portion. So whatever you drag and select, like I dragged and selected this part of the code, right? It will, if I click on it, it will only execute that part of the code. Okay. So that's usually the most used one as well. Second one, if you see, it has a slash T. This means wherever you keep your cursor. So let's say you have multiple more codes over here. Okay. So wherever you keep your cursor, if my cursor is over here, it will execute all the codes till this part. It will execute all the codes till this part, till wherever my cursor is. Got that? Is that clear? Okay, so if you want to, ideally, if you want to execute everything until your cursor, everything from start until wherever your cursor is, you will use the second option. And the most ideal one is just select the query, select the command that you want to execute and click on the first flash button. Okay, that will help you basically execute whatever you selected. The third one is called explain command. That's completely different. We'll learn about it later. When we learn optimization, we'll learn about it later. But just understand that the third one is used to explain your command. Basically, it will tell you that how much memory are you using, how much execution time are you using, etc. Okay. So those are the things to start off with. Here I'll just execute the command. So I can use the first command flash button for executing this, or I can use a simple shortcut, a simple keyboard shortcut, which is basically selecting the command and clicking on Control plus Enter. Command enter or control plus enter. If I just press control plus enter, can you see on the bottom in the action output, I got a green tick mark because my database got created. So it says that it is a success. My database got created. On the left hand side, I still can't see my database that I just created. So what I'll do is, one second, let me just delete this one. I have too many databases, so I'll just delete this one. Okay. Now what I'll do is, beside the schema, you have a small refresh button. If you just click on it, can you see the database that I just created got populated over here? So you created your database successfully. Okay. Right now it has no tables, nothing inside it, but my database is created. My structure is created. So this is this is how you can create a database using command by writing manually. The other way is to basically create it using the taskbar. So you can just click on this fourth option over here on the top. If you click on this fourth option, if you see, it's a database symbol also. If you click on this, it will tell you that this is a schema editor. This is where you can create a new schema. And new schema means creating a new database. So you can give any name over here. Let's say give a name ABC. And if you just click on apply, it will create the same database that I just created with whatever name you want. So two ways to create it, either by using this command or by clicking on this fourth option and actually entering just the name and clicking on apply, and you will basically get the same database created over here. Is this process clear for everyone, firstly? Which part do you want me to repeat? Okay, after creating the database, on the left hand side where you have the schemas, you will see there is a small refresh button. If you click on it, your tables, your databases get refreshed. So it shows the new database that I just created, which is sampling. And the other thing that I said is you can also create a database without writing a command by yourself. You can also use this fourth option on the taskbar. This is used to create a database by using the auto menus that you have. Here you just can give your name, the name of the database that you want, click on apply. It will create a similar database. That's all I said. Is it clear now for everyone?
Hello, Meghna.
Meghna, is there any limit to create databases? Like how many databases can
On
we
your
create?
memory. Depends on your memory storage in your laptop or desktop.
Okay.
Meghna, what is the use of first line, create database, and second? Both are same, I think.
Oh, the first one I said, right, that this is a comment. This is just a comment. This is just like for readability purpose. Just to add more text to your data, to your codes. It's for maintaining code hygiene. Like for example, when you see this code file later, you can just understand that the next command that I've written is for creating a database. So it's for textual description purpose. This never gets executed. Even if you try executing it, nothing will happen basically. So try
Okay,
executing.
okay, clear.
Nothing will happen. Okay, that's it. Got it? So everybody clear till here? Okay, if you guys are clear, can you create your first database? Okay, everybody done, right? Now I have just created a database. Okay, so I have just created a database right now. I have not specified um I've not specified SQL that I am going to use this database. Okay, so whatever data you whatever data you store, whatever tables you create and etc., you will obviously create or do them in some database, right? You'll have to create those tables or database in, you can create those tables or you can store that data in some database. So you have to specify, the next step is you have to specify SQL that I am going to use this database hereafter. Hereafter, I'm going to use this database. This will be my database there where I'll create all the tables, I'll store all the data, I'll do all the operations and etc. So for that, I need those commands called show and use that I was talking about, just few minutes back. So I'll use this command called show databases. When I use this command show databases over here, what this command will do is, if I just run this command, you will see that there is a result that I got. This shows all the database that I have in my system. All the database that I have created till date, it will show me all the databases present. Okay, that's what show does. It basically is used to retrieve information about all the databases and etc. that I have. Okay, now out of this database, I want to use this database. I want to use the one that I have created. I have to tell SQL that I am going to use this. So I'll type use space sampling. So when I run this command, if you see it's a green tick mark, and if you see samplet became bold, that means I'm right now using the samplet database. So whatever work I do hereafter will happen in this particular database. That's the work of show and that's the work of use. Use is basically used to switch to a specific database before you start running any queries that you want to. Is that clear for everyone?
Can we select multiple databases at the same time?
No. Only one database. You can only operate on one database at a time. Okay, cool. So now we have the database. Now we have set SQL that this is the database I'm going to use and operate on. What do you think is the next step that we should do?
Create table or create some data inside the database.
Yes. So next step is getting the data or creating the tables, right? Creating tables and getting data inside it. That's my next step, right? Right? Everyone agrees to that? All right. Now, even for this purpose, even to get data into tables and have tables in your database, there are two ways to do it. Okay. One way is to load the data from anywhere from outside, right? From outside MySQL workbench, you can bring in data inside MySQL workbench, right? That's one thing. Or the second thing is manually creating the table and the data inside MySQL. We'll see both of them, okay? We'll first load the data inside MySQL workbench. So what I'll do is I'll first give you a code file. Give me a minute. Not a code file, my bad. I'll give you a data file. Give me a minute. Okay, I've sent you a data file. Can you guys download the data file? And that data file is in .csv format, which is comma separated value format. Please keep it in the same format. Don't try to store it in Excel or something. Can you guys just download the data file? Everybody done downloading it? Okay, great. So I will, okay, first thing is that when you load data inside MySQL Workbench, when you externally load data inside MySQL Workbench, there is a limitation. That limitation is that you can only load CSV files. CSV files means the files which has an extension .csv, comma separated value files. Only those files can be loaded inside MySQL Workbench, nothing other than that. Okay. So I'll show you how to load it, and the process has multiple steps. Okay, so I want you to pay focus. Okay, so I will load an external data file that I gave you inside the tables of this database that I have created. So I'll click on this tables. This samplet is my database that I created. So inside this tables, I'll click on this database and I'll right click. I'll right click on this database. When I right click on this tables, I have an option called as table data import wizard. So I just right clicked on tables and I got an option table data import wizard. I'll click on it. When I click on table data import wizard, what happens is this dialog box opens up. Okay, this dialog box opens up, which basically allows you to select the file that you want to load. So you can click on browse and you can choose the file that you want to load. I want to exactly load this file. So for me, it is already selected. Okay, you can browse and select the file that you want to load. Click on next. Okay, now here you have options. Do you want to use any existing table? And do you want to drop if the same table exists? Do you want to delete it and recreate it and etc.? In our case, none of those options are valid because we are creating a whole new table. So I'll just keep it as create new table. Okay. This is the database under which I'm creating the table, and this will be the name of the table. Name of the table is coffee underscore sales. I'm just going to click on next. This is where it shows all the columns that is created. You can just go right and see all the things. You don't have to change anything over here. Just click on next, and it will start importing your data file. Okay, so if you see right now it has finished importing the data file. I'll click on next and then finish. Once you click on next and then finish, you basically load the data inside MySQL Workbench. How will you see that? Again, same process. Click on the refresh button. And now if you see under tables, a coffee sales, a new table got created over here. That means I've successfully loaded my data inside MySQL Workbench. Is that clear for everyone? Was this process clear for everyone, guys? Explain which part. Okay, so you can just right click on, this is the database where you are loading the tables, right? So just right click on tables and click on table data import wizard. After you click on that, you will get the dialog box where you can browse and choose your data file. Then you just keep on clicking on next until it finishes. Got it? Is it clear now? You can do it using a script, Priya, but it will be very hard. So that's why this is the best option that we have. Got it? If you guys are clear, can you quickly go ahead and load the data inside MySQL Workbench? Priya, to see it in script, we have to understand the other commands. So I'll have to create a command. I will have to create a table command first. Then I'll have to load data command, and then I'll have to write it. But for that, I need to first understand how to create a table. So after this, we are anyway going to cover the create table command. So maybe you can have a look at that. What about others? Everybody done? All right, cool. Okay, I think we have been constantly having a class since 2 hours. So let's take a break of 20 minutes and we'll be back in 20 minutes. Okay? Okay, are you guys back, everyone? All right, cool. So now we'll move to understanding the manual or syntactic way of creating table. So we'll understand how to create table using MySQL command. So the create table command is something that we are going to use to define a new table, right? So we'll first learn what is the syntax and how does the syntax look like. Okay. So you start with writing the command create table and give a table name. Okay. So whatever table name you want, you can give it. Okay. Also, guys, a very important thing, after you end a command, any query that you write, after you're done writing that command or that query, colon is very important. Semicolon is very important. Okay. So you have to give a semicolon once you finish writing a query, or else it is going to throw an error in the next query because SQL won't understand that the previous command has ended. Okay. So once you finish writing a command, semicolon is very important. Okay. So create table name, give a table name of your choice. Then start writing your columns that you want in your table. Okay. Whatever column you want, you can write it. Give the data type. Okay. Comma. And if there is any constraint, we'll learn about constraint a little later. But if there is any constraints, we can add it over here. Constraints are rules, okay? Again, we'll focus on constraints later, not now, okay? Same way, you can keep mentioning columns and their data types, etc. over here. That's the basic syntax of creating a table. I'll create a table, for instance, right now, okay? So I'll create a table named employees, okay? Now in this table, let's say I have employee ID. So my first column is employee ID. So what do you think can be the data type of employee ID? Integer. Like it can be varchar also, but it's convenient to have it as integer. So I'll have it as integer. So my first column is done. Next, I'll write employee name. Write employee name. So what do you think will be the data type of employee name? Are you sure?
Varchar.
Yeah. Okay, char or varchar?
Varchar.
Varchar, right? Everybody agrees varchar. Varchar, why? Because everyone's name can have different length of characters. Are never sure that, everyone can't have the same number of characters. So obviously char cannot work over here. So varchar. I'll give a maximum size of 50 because I don't think anyone can have the name more than 50 characters. So for now, I'll give 50. Then I'll give age. Age will be what data type? Int, right? Okay. Then I'll give salary. What do you think can be the data type for salary?
No. This
Decimal, yeah, decimal. Float, you can write float as well, but since this is a number which is related to again financial data which is related to finance, money, salaries, transactions, etc. It's better if we store it in decimal because everything will be having exactly two decimal places. So it's good. Okay, so we'll write decimal 10, comma. Maybe I can have one more column called department. Okay, so what do you think can be the data type for department?
Varchar.
Where can, right? Where can, same thing, I'll give 50 characters max. And now I'm done. I'm done writing the command for creating a table called employees. What I'll do is I'll just run this, I'll just select and I'll run this command. Once I do that, if you refresh on the left, if you see, employees table is created. See, employees table is created just the way you want. So right now, what do you think? What is there in the table? What is present inside the table?
Empty.
The column name.
Exactly. Only the column names, right? Nothing else. It's empty, right?
Yes.
Right. So that's because I have created just the structure. That's why create is a DDL command and insert is a DML command because create is just helping you create a structure for your table. The values or the data that will go inside the data table is, inserted, the data values are inserted using insert command. So insert is the command, which is a DML command. We learned about it, right? We use insert to insert rows or data inside our table manually. Got that? Right? Now, someone asked me, right, that what if I want to load the data using code? We just loaded the data using table data import wizard, right? If you want to load it using code, you will use a load data command. So you can write load data in file and you can mention the path of the file, whatever your file name path is, wherever your data is stored in the laptop or desktop or wherever. Into table employees. That means I am loading this data into the table that I just created. So whatever table structure you create, that's an empty table structure. Now you're externally loading the data into MySQL Workbench and into this particular table. And you can write external commands like fields over here, I think. Yeah, fields terminated by, basically whatever is your separator, you can give comma. Then lines terminated by, what are your lines separated by? In your raw file, you can mention that. Slash n means new line. If you want to ignore the first row, let's say you want to ignore the first row because you already have column headers over here, you can write ignore row once. And that will help you create the file from scratch manually, okay? But this is something we very rarely do. I'll tell you why. Because sometimes your MySQL is not will not be able to connect to the path where you have locally stored the data. Okay, so these kind of things are good when you're using a live database connection, right? Something like, for example, in companies or in real world, companies have data lakes, they have cloud data storages, clusters where they store data. So I can directly fetch that data from there, and I can insert over there very easily because it's connected. Here sometimes the connection fails because this is like just for exploration and purpose, right? I mean, just for exploration and learning purpose. So it's better if we learn how to insert the data manually. But just because you asked for it, I just mentioned you the script over here. Got it, Priya? All right. Now I have created the table structure. I will insert the data inside it. And for insertion, I will use the command called insert. So I'll type insert into. Where am I inserting the table? Where am I inserting the data? I'm inserting the data in employees. Okay. Now, ideally, when you insert into employees, whichever table you are inserting into, ideally in bracket, you mention the columns. All the columns, comma separated, you mention it over here and then you give your values. Same way. Okay, so let's say you wrote column 1, column 2, column 3. So if you mention 3 columns over here in this order, in the same order over here also you will mention the values, whatever values you have. And that will create your first row, which is ABC. That's the ideal syntax, okay? But since we are creating the table from scratch, we will like to enter data to all the columns. Am I right? So when you want to insert data for all columns, only in that case, only when you want to enter data for all columns, only in that case, you need not mention the column name. So you can directly write insert into employees values. And you can start mentioning the values over here. So what is my first column? Employee ID. So let's say my first employee ID is having ID 1. Name is, let's say, Alice. Let's say age is 30. Let's say salary is 1000.70 and department is, let's say, HR. Okay. And let's say you can enter multiple rows. So this forms my first row. Second row will be just give a comma and again within bracket give your values. Let's say to Bob, who is of the age 27, earning 70,000, some value, comma. Department is, let's say, IT. Okay. And likewise, you can enter multiple rows over here. So I'll just quickly enter a few rows. I'm just manually entering values over here.
If we miss any row, then the
Well,
values mostly.
it will throw an error. If you have, like, for example, 1, 2, 3, 4, 5 columns,
Mhm.
and you have not mentioned which columns you're entering for, SQL by default understands that you are trying to enter values for all the 5 columns in the same order that you have declared it. So you have to mention all the 5 values. If you don't, it will throw an error.
Okay.
Okay, I'm done inserting the row. Okay, now what happens is, if you, let's say, only want to insert into employees, let's say you only want to enter values for employee ID, the name, and the age. You only want to enter these values, okay? So you will only mention these columns, okay? And give the IDs likewise. 7, and let's say the name is something like E, and age is, let's say, something like 35.
Since we have here only 5 columns. So suppose there is a table and which have around 100 columns. So how we will get all the columns name to choose?
So we don't usually enter values manually, right? We are learning, so we are creating it manually. But when you have 100 columns, you will definitely not create it manually because it's not
No, no,
possible.
I'm just saying that how we can see all the column. The so
Oh yeah,
column.
I'll show you that. Yeah, 1 second. I'll show you that. Okay. So if I just want to add like if I just want to add these values only for these columns, I'll just do that. Now, first thing, just see how do you know that you have inserted the data? How do you check if the data is inserted correctly? For that, you need to write a query to retrieve data. And which is the command that we use to retrieve data, guys? Can anyone tell me if you
Select,
remember?
select.
Select, right? Select. So the syntax for select is basically, well, I mean, select has multiple parts, okay? We call it clauses. Select has multiple clauses, okay? But we are going to understand the mandatory and the most basic one first, okay? So you start with select, you mention your columns. Whatever column you want to select, you mention it over here. You can separate them like this: column 1, column 2, column 3. So this select part is just to showcase these columns in the output. So whatever order you write it in, that same order will come out in the output. So remember this always, that in this select statement, whatever you are selecting, whatever column you are selecting is just used to format your output. This is just used to showcase your output. However you want your output to be, whatever you want to get displayed in the output, you will basically format things likewise, okay? But once you write the select statement, you also have to specify that from where are you selecting. So you will write from table name, colon. Okay, so this syntax is basically saying that from this particular table I am selecting these columns. So the output will only show column 1, column 2, and column 3 in the exact same order. So if you want to format your output, if you want to show some other column or etc., select will basically be the place where you can tweak and work. If you want to show all columns, then you are going to use asterisk. So instead of writing select employee ID, comma, name, comma, age, comma, salary, comma, department, like instead of writing all these, even if you write all these from employees, you will get the data, 100% you will get the data. See, you are getting the output over here, right? That here this is the table that we just created. So you're getting the output, but instead of, if you want to showcase all the columns over here, instead of manually specifying all the column names over here, I'll instead write select star from employees. So when you write select star, you mean to say that I'm selecting all the columns over here, and all the columns will basically get selected and you'll get the same output. So when you have a lot of columns, instead of manually selecting them, you can use select star. And if you want to see your columns also, if you want to see all your columns also, if you can just click on the table on the left hand side, you can see all the columns over here as well. Got that? Is it clear till here?
Point out, Meghna. You have inserted one row separately that
Hmm.
there you are defining the column names and you inserted data for only for three columns.
Hmm.
So here in the values, if we give the same employee ID which is already we have inserted it, what will happen?
Duplicate row will get entered. Another row for employee ID 7 will get entered. We have ways to, manage it. We have ways to handle these things. That those are called constraints, which we will learn later.
Oh, okay.
Since we only entered value for 3 columns and not the other two, so that's the reason why the other two is missing, which is represented by null. Got it? Everybody clear till here? Can I get some more responses? Okay. Now, if you want to, if you just want to see all columns and etc. from a table, you can also use just to see the columns, not to see the data. Okay. See, select is used to fetch data from tables. Select is used to fetch data, retrieve data, or query data directly from the tables. So it will give you everything about the values also stored inside the table. But if you just want to see the columns, the column names, let me be very specific, then you can write show columns from employees. This will just show you all the columns that we have. See, only the columns, and it will tell you what is the column name, data type, does it contain null values, or etc. Is it clear till you? So are you guys clear with everything that we explained till here? Everybody clear? Okay. Can you guys quickly complete your execution till here?
Meghna,
Yeah.
here it is showing employee ID, name, age also are having nulls, right? But
Yeah.
actually, we have entered for only one row, that also for salary and department is
Right.
null.
Right. Yeah.
But why it is showing for other three columns?
That's because it's showing that I have not added any constraint. I have not added any rule that these columns cannot have nulls. If you want, you can add that rule and that restriction that these columns cannot store null values. So that's why it is showing yes, because it can store null values basically.
Okay, okay. I thought based on the value we stored, it is showing the null.
No, no, it's showing that if it can store nulls.
Okay.
Make sure you create your table and insert values and etc. also inside it.
Meghna,
Yeah.
Meghna, can you scroll up once creating the employees table?
Yeah. This one?
Yeah,
Okay.
yeah, okay. I got error, that's all.
All right, all right. Okay, let me know, guys. Once you're done, just let me know. Was I audible, by the way? I'm not sure. Okay, cool. Okay, I just got 4 done. From others, I also want a response if you guys are done as well. Okay, any questions, any doubts that you guys have till here?
Can we rename a table name or
Yeah,
database
we
name?
can. We can.
Okay.
There are commands for that, and the command is rename command. We'll explore DDL commands in detail, but also if you just right click on it, you will see there are options of altering the table and etc. So you can explore these commands. So these are the ones where you don't need to write a command, though you can obviously do the same thing using a command as also. But if you can right click and work along with it, that also works. Okay, but not everywhere will you get this option of right clicking and doing alterations. So it's good to learn the commands that way.
Okay.
Okay. What about others? Any other questions, any other doubts that anyone has? Okay, so were we all clear with all the questions, all the topics that we covered today? Yeah, I will share the codes. Give me a minute. I'm just preparing that file. Give me a minute. Okay, so I've sent a Google Doc link in the chat box. Let me know if you can access it, if you can, see the codes and the notes for today. I've appended everything in the same doc file. Everybody can access, right? Okay, then that's great. All right, cool. Okay, I can still take up 5 minutes, and if you have any doubts and questions, I can answer it. Anything anyone wants to ask?
Sorry, where did you share the code and everything?
Even in the chat box, I've shared a link. I'll share it again.
Oh, got it.
Yeah. Okay, then cool guys. Thank you for joining in. I'll see you guys again in the next week. And yeah, thank you.